My name is Thomas Beyer. I'm the research coordinator of an ITN project called HYBRID. HYBRID stands for Healthcare Yearns for Bright Researchers for Imaging Data. The idea of HYBRID is to raise a handful of early stage researchers, to be specific, 15 of them, at various high-level imaging centers throughout Europe, so that they can support the concept of personalized medicine, both in research as well as clinical translation. Personalized medicine is a concept for finding the right patients through different means of diagnostic pathways and help them tailor to the right treatment at the right time, and also help observe whether a specific treatment is given over time and also helps these patients during the course of their disease. HYBRID puts together 15 early-stage researchers at 11 beneficiary sites. These are academic hospitals as well as non-academic beneficiaries, such as industries, as well as 12 partner organizations who specifically support these activities through education at all levels across academic know-how as well as business know-how. So at the end of this project, which runs for 4 years, the early stage researchers have experienced multiple pathways of their engagement in both industry and academia. HYBRID falls into 3 work packages that are all centered around personalized medicine with a specific focus on imaging. In particular, we try to source biomarkers that are both quantitative as well as reproducible from standalone imaging, but more so from hybrid imaging. Hybrid imaging really is a combination of anatomical and molecular imaging, which is known to provide additional and very helpful and unique information for judging particular stages of disease. The work packages are really 3 in which we put these different academic projects into. One work package is called data collection, and work package 1 relates to this. And the idea is that we actually generate cohorts of data, primarily imaging data, but also non-imaging data, such as liquid biopsy samples, histopathological specimens, etc. And these data cohorts of these aforementioned patients undergoing imaging exams at various imaging sites are collected so that we can draw from these data sets during the course of the subsequent work packages. One very specific aspect of this data collection is that we also want to provide means that we can use these data as acquired from multiple sites and at multiple and different imaging conditions. These data are then being used at a work package 2, which is really related to data analysis. And what this means is that we want to find optimum pathways of using individual image information, such as from static images, where we look at really voxelized data analysis, also judging on heterogeneity of tumors, for example. But in addition, we want to make use of the dynamic pathways and dynamic changes of these biomarkers, which we believe holds an extra set of information that could be sourced as part of the data analysis pathway. In addition, these data come, of course, multiplexed, meaning that we can acquire the same patient in multiple imaging modalities, and again, this adds to the complexity of data. So we want to make sure that we source the maximum information from the available image and non-imaging data. This is a very research-oriented work package where the ultimate goal is really to translate this into clinical practice. And this is work package number 3, where we want to make sure that whatever insight we generate from the data analysis of multiparametric imaging is applicable to other patients with a specific disease and patients that undergo treatment planning or diagnostic pathways at hospitals that follow their local protocols. This clinical translation in particular relates to the ability of using machine learning for deducing therapy response prediction, for example, but it also relates to rather simple approaches where we propose workflows that are highly efficient and most effective. Last not least, we want to translate the image information and associated quantitative data into, for example, image-guided bioptic sampling, or ways where we can use invasive methods to extract further tissue samples or examples of these patients. Overall, this is a continuous plan where we move from initial diagnosis to advanced data analysis, including multiparametric data analysis, to clinical translation. If working out well at the end of this 4-year period, we will manage to have 15 very well-educated early-stage researchers with a PhD degree from various universities who hopefully will shape the world of imaging in the next decade. If you want to find out more, check out our webpage hybrid2020 EU. We look forward to your comments. Thank you.